extended his research in the area of neurological signal processing and developed methodologies for improving the performance of the BCI system during his doctoral degree program. As an assistant professor in the esteemed Thapa Institute of Engineering and Technology, Patiala, he has supervised 4 master's dissertations and currently supervising 5 PhD research fellows in the area of BCI and neurological disorders. He's recently completed his postdoctoral research work from Rayleigh Lab, I think, in Trinity College Institute of Neuroscience, Trinity College, Dublin, Ireland. He has authored more than 30 research articles in the peer-reviewed journals and reputed international conference proceedings. He serves on the review boards for various journals of IEEE, Elsevier, Springer, and Wiley. I think, sir, I have pronounced the technical terms correctly. I'm
Yeah, sir,
definitely
fine,
sure.
sir.
Okay, yes. Yes, Dr. Rahul Upadhyay, if you are ready, you can start your presentation, sir.
Sir, thank you very much for the brief introduction. And I will try to keep my presentation in a way that I can give as much as knowledge which can be useful for the student at this point in time. And if they also are willing to do masters or higher degree program in the area of AI or data sciences, they will also feel that this area is how much promising and how much is growth in this particular area. So I will try to keep things in a way so they are basic as well as advanced in some extent, and I will try to get their focus and interest in this particular area of research, uh, which is growing day by day, and this growth is phenomenal. So So as Prasanna sir has already introduced me, I am Dr. Rahul Upadhyay. I am assistant professor here in Thapar Institute of Engineering and Technology, Punjab since June 2016. So the outline of today's discussions are going to be, or I would rather say that after this presentation, you would be able to answer some of the fundamental questions related to AI. So the very first and fundamental question, what the AI is all about and what's the AI? What is the need of AI and where it can be applied? AI in healthcare, which is the basic topic on today's discussion. Then AI for remote health monitoring. So I would be touching that topic a little bit. And then I will also give you some of the glimpse of the activities, research activities, basically, what we do usually in TIIT Patiala with our student in the research group. So with the very fundamental question, what is artificial intelligence? So this term was first coined in the year of 1955 with an article which was published by John McCarthy. He was basically from the Dartmouth College, and he was having his colleagues as well, who were from Stanford universities and different institutions, renowned institutions from US. And the article named as 2-month 10-man study of artificial intelligence. So this was the first time when this artificial intelligence term was coined by someone. Following this year, 1955, in 1956, another workshop took place, and it was organized by the same fellows, and it was in the near about July to August 1956. And in this conference or the workshop, a paper was presented, and that paper was basically telling what the capability is artificial intelligence is. So this paper was coming from some of the renowned institutions from America, and this paper, which was published in 1956 in the same workshop, they basically solved a checkers game problem. So this is a checkers game problem, which is a problem of some strategy board problem. You can call it a strategy board problem. And they formed the strategy by the machine learning or the artificial intelligence. And these participating institutes were MIT, which is one of the most renowned institutes in technology. It's the Massachusetts Institute of Technology, then Carnegie Mellon University, and then IBM company. So there were these three participating institutions, and there were scientists and students and research fellows who was working on this AI problem, and they solved checkers game problem using artificial intelligence. And everybody, it shocked everybody in that point in time, because the efficiency and the accuracy of this checkers game problem was higher than the average person who plays this particular game. So this was the first time when world saw the capability of artificial intelligence, right? So this paper was published in 1956, and they were working upon this particular problem. They had been kept on improving upon this particular game problem, and later on they saw the capability of artificial intelligence with the word like how this thing is going to be a big animal in the coming future. So what is an AI? How we can define an AI? So AI traditionally refers to an artificial creation of human-like intelligence that can learn, reason, plan, perceive, or process natural language. Or if I go a little beyond than that, I can call it, it can process natural data. Just in the same way a human being also do. We process lot of amount of information, lots of amount of information always kept on coming to us in terms of some sensory information to our brain, and our brain is all the time processing that information, trying to extract some basically I should call it a data, right? So it's regularly continuously getting the data, and it tries to extract some of the important information out of it, which information can be used to take some decisions. It can also use to develop the logic and develop the reasoning out of it. So that amount of data that we regularly perceive or receive from our sensory part of our brain, that helps us to absorb the absorb our environment and the information all around us, right? So this is the basic fundamental concept how a human being survive or thrive in this world. We always receive a lot of information, and we extract some so a lot of data, and we extract some information out of that data, and based on that information we always take some decision based on the reasoning or the logic that's being developed on that data. We take the decision so that in a particular scenario or the environment we can survive or thrive. But our brain does not know like how that information is being extracted out of that data, right? But still we are capable of extracting that data and able to make the decision or the reasoning out of it. Just for a small example, if I place an apple and an orange in front of you, you are able to make a decision like which one is the apple and which one is the orange, right? You have been given so many examples during your childhood, like apple does look like this and orange does look like this. So you have already seen a number of examples of apples and a number of examples of oranges. So you do have seen a potential examples of apple and oranges, and you know how an apple look likes and how an orange look likes, but you do not know how that information has been extracted out of the images of the apples and the oranges. So that basic knowledge that you don't know how you have actually extracted that information, but your brain knows what is an apple and what is an orange. So that decision or the classification our brain is capable of making. The similar kind of understanding we are also willing to give to the computers. We are trying to make our computers more intelligent so that they can recognize between two different objects. May it be a very small problem, but in a more sophisticated way, it can take the decision which we as a human being take. It can be a very simple problem where we are trying to classify between fruits, where we are trying to classify between different colors, where we are trying to classify between different genders, or may it be a very sophisticated problem where we are giving an AI to drive a self-driven car or self-autonomous car, semi-autonomous car may it be. So up to that sophistication level, this AI can perform from the basic, very basic level where we are trying to classify between 2 or 3 different classes, right? So that type of intelligence, the human intelligence, we are trying to curate within a machine which can take the decision, make the strategies to solve a problem, or simply can make the decision or make the classification between two different set of data sets. So basic task of, this was a basic task, not the advanced one. Now there have been many advanced versions of the AI, but the basic task of AI was to map input A to input B, right? So very basic examples I have tried to take in over here so that you would be having some feeling or understanding how AI can be used for solving a specific set of problems. So the very first problem or the first application that I take over here is the spam filters. We all have spam filters in our email, may it be our personal email or it may be institutional emails. We always have these spam filters embedded in our emails. And these spam filters, they keep on improving with time as they see different examples, right? You also do have a facility to define a particular email as an spam or a particular email is not an spam, right? So as you keep on giving inputs to your system or the machine and telling it that this particular email was not an spam, this particular email was an spam, and based on the experiences that it learned from, and it keeps on getting better and better and better, and it not only works on your machine, it also is going to learn from your machine and going to work on the different machines as well. So they always keep on communicating among different machines. They learn the patterns of the human behavior, and based on the human behavior, they understand like how they should perform, right? So in the email application where we are going to filter these spams, the classification can be 0 or 1, which means a particular email is an spam or particular email is not a spam. So your application or the problem is very, very simple over here. There's a binary decision which your AI needs to take, right? Now, we are moving towards more sophisticated problem where what we are going to do is change the audio or the translate the audio to the speech or to the text transcript, right? So that's the more sophisticated problem where your AI is going to continuously listen what somebody is saying and has to recognize the different words and has to convert those words to the transcript, right? That's a more sophisticated problem, and we can categorize that particular type of applications as the speech recognition systems. If we further move, the more sophisticated things or the applications are the machine translations, where we always try to translate the languages from one language to another language. So the very good example for this particular application is the Google Lens. So in the Google Lens, you just put your camera in front of one type of text and you can convert it to English. May it be French, may it be German, may it be any other language written on some equipment or any other place. You just put your camera on that and you can translate through Google Lens to English, right? So that machine translation, that's also comes through AI. So one of the sophisticated application of artificial intelligence. Self-driving car. So these self-driving cars, once there was a time when it used to think that self-driving cars not possible, but now Tesla has made this dream possible, and they are having some semi-autonomous car. I won't call it to be the complete autonomous one, but these are the semi-autonomous car where they continuously process a lot of information that comes from the images or the cameras, which are embedded with the car, and also the GPS information. They are continuously tracking or monitoring it. And based on this information that they are getting continuously in the real time through different cameras or the GPS sensors, and they process that data in real time and take the decision. They always stick to one lane, and whenever it is required to take turns, they decide in which particular direction they have to go. They take turn, and then they maintain on the same lane, right? So these are the further more sophisticated example of the AI, like what AI can do. Okay, so another application of AI can be the defect detection. Defect detection may, I can give you example like, suppose there is a product, may that product be a mobile in this particular scenario, And if I have to detect that a particular mobile is having some sort of defect or not, what I can do, I can pass it through an assembly line, and there is a camera. That camera is going to take the snap of that mobile, and then there is a sophisticated image processing software where significant features or the patterns of a mobile is going to be extracted, and based on these features there is a AI based algorithm which is going to classify whether this image is depicting a defective mobile product or not, right? So this is again 0-1 kind of a problem, but this basically deals with the computer vision mostly. So from very basic to very advanced type of application, you can find AI everywhere, right? It's making our lives easy, the environment more comfortable, and as we will proceed with today's presentation, you will understand like how AI is everywhere in today's lives and how it's impacting each and everyone's life, right? So this is very basic problem. Again, I have tried to take it over here so that you can understand how AI can do these kind of jobs as well. So this is one competition which is being organized by Kaggle, and it's known as the Kaggle Challenge. So Kaggle is a website which always keep on putting different type of challenges. In those challenges, basically we have to make the classification of the images, we have to make the classification of signals or different sort of data, right? So they put these kind of challenges, and students or the participating teams have to design the algorithm to train upon that particular data, may it be image or a signal or any other statistical information. So they have to train their architecture, whatever architecture, AI architecture they have made, and then they have to classify. Based on the classification accuracy and classifier performance, awards being given to a particular team who are the winner team. So there are first, second, and third run-ups. So this Kaggle website, if you go onto the Kaggle website, you will figure out there are different type of competitions are available. And this is one of the examples that I have taken over here. In this example, we are trying to classify among two different type of images. In the one image, there will be a dog, and in another image, there will be a cat, right? Now, if you write a script to define how a dogs look like and how a cat look like, that is going to take tremendous amount of efforts, and still you cannot say that in the 100% you would be able to classify or identify a dog out of an image, because you have to first take an image, then you will have to extract the features that look like a dog, then you have to match those features with whatever script that you have written. So it's going to take a lot of efforts, many lines of codes, and still there is no guarantee that you would be able to classify or identify a dog out of an image and a cat out of an image. So this is the first challenge which I am going to discuss today, in which a machine learning algorithm or artificial intelligence algorithm will be given a multiple examples of dogs and multiple examples of cats, and they would be learning upon those data sets. Now, this learning process, when I call about when I talk about the neural network specifically, which is the more modern type of AI algorithm or AI technique, the training thing is completely blind to us. We don't know how it's going to train, right? Although we design the way or design the pattern how it can translate that knowledge that's being inferred from the images to the algorithm, but that training part is always blind to us, like how it's going to take place, okay? Because there are many number of weights and many number of mathematical equations, it's very difficult for us to keep track, like how those weights are modifying, how those links are modifying. So that's a very difficult job to do. So instead, what we do, we make a strategy how algorithm should be designed or how a structure should be designed and how their weights should be modified. But in real time, how that thing is happening, it's very, very blind to us. We don't know how the weights are going to be changed. Otherwise, what we can do, we can take a small network, a small neural network, and we can train that small neural network with very small amount of data. There we would be able to see the changes in the weights and the links. But when there comes to be thousands of images, a data of very big size, it becomes sometimes very difficult for us to understand. That's why we most of the time we call the neural networks as a blind networks. We are blind to us, right? they are blind to us. We are not knowing how those weights are keep on changing, right? So these are big mathematical equations. So the more modern AI methods, which also incorporates the neural networks and deep learning methods. So they are different architecture and models for neural networks and deep learning methods, and new models are always keep on coming. They are being adapted to take these kind of jobs, right? One of the job which I have discussed right now is classifying two types of images. Where is in one image there is dog, and in another image there is a cat. So that may look like very simple example, but when it comes to machine learning, you will have to give thousands of images in order to learn the machine learning algorithm accurately, like how a dog looks, how a dog's look like, and how a cat does look like. Okay, so if you go to this website and look for this particular challenge, which is a computer vision problem, you will figure out around roughly around 30 to 40,000 images you will find of one category, and 30 to 40,000 images are of a different category. We always try to keep the data to be balanced. Like for the one class, we should have almost similar same number of images or the signals. For the different class also, we should have same number of images or the signals. So we always try to keep the balance of data for different classes, right? So you can also see, you can go to YouTube, and on YouTube you will find there is a channel. The channel name is Google Developers. In that channel, this Machine Learning Foundation episode 6, if you will go, they have designed a convolution neural network which is used to classify among cats and the dogs. So if you go to this particular channel and browse for this particular episode over there, you will find out how a convolution neural network, which is a type of artificial intelligence method, can be designed and being trained, and later we can also see how it can be validated on the data for the accuracy, right? To have the accuracy of trained networks. So I would suggest you go to this Google Developer channel on YouTube, look for convolutional cat and dogs problem, and then you will be having an understanding how a network can be trained with the data set, and how we validate the performance of that particular network, right? So I have taken many terms right now. I have taken terms like AI, then neural network, then deep learning, right? They all fall under the same umbrella of AI. AI is a superset or is a broader term. Within the AI, the neural network and deep learning methods comes, right? And the overall purpose of AI is to learn the human behavior, human understanding, human thinking, and learning. That means we want to give that understanding of a human behavior to the machine, so that your machine becomes more sophisticated, or your computer becomes more sophisticated, and it behaves like a human being, right? So this is a very basic architecture of neural network. Rather, I will call it an artificial neural network, although this term is being inspired by the neurons or the neural network that we do have in our brain. So the very small computing unit that we do have in our brain is called the neuron. So there is one neuron, and then there are trillions of neurons in our brain, and we do have millions of connections between these trillions of neurons within our brain. And these connection with new learnings, the connections are being made or break, and they always keep on changing. Those connections always keep on changing. Their strength of the connections that also keep on varying with the different learnings or the environment that we come upon. So that's all about brain. So that neural network is basically inspired from the brain, but it's not exactly depicting how a brain functions, because in brain there are neurons, and those neurons keep on communicating with each other with very small impulses of electricity, and that electricity can be uh, measured by the electrodes, and that signal that what we get out of those electrodes is known as the electroencephalogram signals. You all know it as an EEG, right? So they are a very small neurons within our brain. There are million trillions of neurons. All those neurons are connected to each other. If they are connected very much in strength, they represent a specific type of knowledge. If they are distributed and weakened, they represent a separated type of knowledge or separate mapping, right? So that concept basically is being brought in this area of neural network. And here also, the smallest computing unit is going to be neuron. Now, this neuron is connected with different neurons, and we do have different layers as well. Now, in one layer, there can be multiple neurons, right? So in this particular example over here, you can see we do have three different layers. One is the input layer, then is the hidden layer, and then is the output layer. User is always having exposure to input layer and the output layer, and hidden layer is always hidden to the user. We do not have the information of what is happening inside the hidden layer, right? How bits are changing, how the synapses are changing, how their links are changing. So that information we do not have. We are having exposure to the input layer and the output layer, right? Now, what can be the input? In the example just now I have given, where I have shown you the picture where there was a dog and there was a cat. Now, in the input layer, we are going to give lots of information. We are going to flood in number of images as an information to the input layer, and the target or the output layer is going to give you the classification whether the given image was the dog's image or was it the cat's image, right? So input can be anything. Input is the information which is going to be transformed into the knowledge on the output side, right? Or we simply call it the mapping, A to B mapping. Input is A and target is B. May it be a spam filter? If it's a spam filter application, so input is going to be the type of spam, their category, and we can keep some of the keywords as an input. Like if this certain type of keywords are going to be there in the email, we will classify that email as an spam. So at the input side, we are going to give the parameters which are going to define the information, and based on the information, we are going to take the decision whether that information refers to this particular type of class or a different type of class, right? So all these neurons, they are all mathematical equations, their weights, they are all mathematical things. So, and there are different training methods which can be used in order to represent the knowledge that we have in terms of the output, right? Now, all the examples that I have taken just now are representing a specific type of problem which is known as the supervised learning problem. Now, what does this supervised learning means? So supervised means you have a supervisor who is continuously telling you like what are you dealing with, right? So if I have placed an apple in front of you, and if I have placed an orange in front of you, I have told you that this is how apple does look like, this is how orange does look like. You have shown a countless number of examples of apples and the oranges, and now you do have an understanding how apple does look like and how orange does look like. But the very basic thing which requires to take place is a supervisor. There should be a supervisor which tells you that this is this type of data and this is a separate category of data, right? So that classification should be already available with the data when you are doing the training thing, right? So we are talking about the labeled examples. That term is called the labeled examples. We do have labeled examples. That means we do have an image of apple and it says that this is an apple. We do have an image of orange and it says that this is an orange, right? So that kind of segregation or the classification we do already available, we do have available with our examples. So all our examples are the labeled examples, okay? And if we train our network or AI method with the labeled examples, that comes or falls under the category of supervised learning problem, right? So we do have a supervisor which keeps on telling to the system that this is a one category of problem and this is another category of problem or other type of problem, right? So another example which is worth sharing over here can be house price prediction problem, right? So suppose you have a software. You have to design a software which tells you like how should be the probable price of your house. So what will be the different input for predicting the price? Now the input can be first, what is the area? of that house. Second, how many bedrooms are there in that house? How many bathrooms or toilets are there in their house? It had been renewed or renovated recently. In which locality this house is. So we are having 5 different inputs. And based on these 5 different inputs, we have given some sample prices to the system or the network that if this type of inputs occur, the price should lie in this particular range. So you have given a number of examples to your network that if these 5 inputs are having this bound of information, this range of information, that the price of that house should lie in this particular range. So now your network has already seen a number of example, a handful number of example, and it understand like how we can map these input values to the price value of that particular house. Now your system or the software can be deployed in real time, and what you can do, you can put any user can give all those inputs and can predict that what will be the cost of that their house. Now these type of systems are already being in use, and if you will go to search for uh, some of the website which deal with the cars, old cars, second-hand cars, they are having those prediction filters available with them, where you are going to give the model number, you are going to give the model, which year that model is being produced, and is it the first hand or second hand already, and in which state it has been registered. So based on these various inputs, these softwares predict what can be the probable cost or the maximum cost you can get after selling that car. So they usually give a prediction in minimum and the output maximum range, right? So you would be having an idea like what will be the minimum cost I will be getting, minimum price I will be getting, and what is the maximum price I can get out of it, right? So this is just a small example. I try to familiarize you with the applications of AI, how AI can be used in the different applications. I'm also going to tell you a little more information so you would be having a clear understanding what the AI is and why it is needed and where it can be applied, right? So whatever discussion we had up till now, the first important piece of information is data. This concept we have gathered, right? If you have data, that data is being supplied to the network or the AI algorithm. If that data is not processed, if it is not being taken care of before it's being used to train the algorithm, your algorithm is not going to train accurately. And thus, the output of algorithm is not going to be the way you want it, right? So the most fundamental piece of information is the data, which is going to be used to train the model. So whenever we design a model and when we train this model with labeled examples, we carefully look upon each and every example. Is the example is accurate to be given to the system, or if it is not, right? So we should discard all the examples which do not qualify on a certain criteria, and we take only those examples which qualifies to be used or given to the neural network for training, right? So this is the very important concept that we need to understand, that the data which is or the labeled examples which your AI system is going to see to learn or to train, that should have been curated very carefully, right? So now AI has many tools. The first tool can be machine learning and the data science. Now many people call that machine learning, data sciences fall into the category of or under the umbrella of AI. There are many other people who says that AI falls under the umbrella of data science. However, the correct thing, if we put this thing correctly, if you should say that data science, uh, it it takes some knowledge from AI, it takes some knowledge from deep learning, and it does also have some separate concepts to implement, right? So the very first tool or one category of tool that's being used in AI is the machine learning and the data sciences. Now the machine learning many times people use machine learning as an extensible term to AI, and we can call machine learning as a subset of AI, where the main objective or goal is to teach or learn your machine without explicitly programming it, right? So your machine is not going to be explicitly programmed, still it is going to learn through the examples, right? And this is the subset of AI. AI is a broader term where we always try to make our machine more and more intelligent and behave more like a human being, right? Now, machine learning can be one subset of AI where we mostly deal with the classification type of problems or the regression type of problems. So one example where we classified between dog image and the cat image was the classification problem. Rather, the different problem where we predicted the price of the house was a regression type of a problem, right? So that's being done by the machine learning. So there are many algorithms for machine learning and AI that we are also going to see in today's discussion. And in data science, what we do, we basically try to extract valuable information out of the data, right? So it mostly deals with the representation of the data. Okay, in today's world, lots of information is coming all the time. So there is a flood of information is coming to the systems. There are many sensors and other statistics are available. So like in 10 years back or 20 years back, you cannot expect to have this much amount of data. So the new field has emerged in past 5 to 10 years, which is known as the big data, which basically deals with the enormous amount of data and try to extract some significant information which can be used for the decision making, right? So that's a separate branch which is being dealt with by data science, but that also falls under category of AI, or at least we can call it, it shares some of the concept with AI. Now, another category which is being referred as the modern AI techniques is called this deep learning and the neural networks. They are also interchangeably used, deep learning and neural networks, right? Uh, in today's world, there are many different types of networks are available, and every time, like in every 1 or 2 years, I see that new type of architecture is being coming. Like for mobiles, they are having a different architecture which is known as the mobile net. For computers, for sophisticated problems which deals with large amount of data, they do have separate type of networks made called Alexa net or VGG16 net. So there are different type of networks, right? So depending upon which type of problem we are going to deal with, the nature of the problem is going to be the deciding factor which type of network we are going to use. If our problem is very light, it's going to run on the mobile, it's better to go with the mobile net, right? So we will be taking the mobile net, we will train it, and we'll use the way we want it, right? So, but apart from these 3 or 4 terminologies, which is machine learning, data science, deep learning, and neural network. There are other buzzwords as well, which is also the some of the type of the tools which are being used in AI, made called as unsupervised learning, reinforced learning, and knowledge graphs. So I'm not going to go into the deep in these methods, but these are some of the words which I want you to have a look upon after the presentation. Whenever you get time, if you are interested in this particular area, just Google these terms and you will be having a good idea like what these terms are all about, what they deal with, right? Fortunately, there is a lot of resources that are available in today's world, um, and a lot of free resources is available, what I could call it. So if you go to YouTube, you will see there is multiple channels are available. There are many people who are working very hard to deploy these type of knowledges onto this, on these muses, and you will get to learn a lot many from those platforms, right? I'm also going to share with you some of the web pages, some of the channels, and some of the websites from where you can get a good knowledge. And if you want to like work in this particular area, there are many resources that are available to learn, right? It's just you need to be open to learn. So we use AI, but we don't know like where we are using it, right? So I will be quickly going through these applications. I had made many slides. I don't know how many I would be able to complete, but I will try to like go a little fast from here onwards. So there are some of the applications where AI is being used precedently. So one of the application is in the smartphones where like the tilt feature where you tilt your mobile and automatically your screen also rotates by 90 degree or 180 degree or whatever whatsoever is a feature of artificial intelligence. Okay. Apart from that, the automatic brightness that is also part of AI where there is a sensor which continuously senses the environment light in terms of luminances and based on the environmental light, the sensor's input, your AI algorithm is going to take decision how much should be the appropriate brightness, right? Then there's AI cameras. AI cameras are much more sophisticated application of artificial intelligence, which are also being used for brightness correction, sharpness correction in the night modes. And if you have already taken your picture for the post processing, also you can use these AI based methods like in the many Vivos and these Oppo cameras, you would have seen like how your selfie camera works, right? That selfie is many a times much brighter and much more clear, and you won't be able to see the dark spots or black heads if you do have in the images that's being captured by the selfie cameras, because they do have those type of processing already inbuilt with their systems, right? So apart from that, we do also have smart assistants, which are the voice assistant. It may be a Google Assistant or Alexa or Siri. Then there is one advanced features which is also being featured by the Android phones. It's already being available with many flagship mobiles, but maybe it's not that very common, where we can adapt the battery charging. Like if you want to charge your mobile, like if you plug in your mobile for charging at night and it's going to be charged for whole night, in the morning 10 o'clock if you want it to be charged, what it will do, it will switch on the charger for some time, it will keep on charging, then it will stop charging, then if you want it to be full charge by 10 a.m, it will again rapidly charge for 5 or 10 minutes. At the time of 10 a.m you will get your mobile completely charged, so that charging is adaptive, right? So that's an advanced feature which is also being offered by the some of the flagship mobiles. Maybe it will be much more common in the later years. So Qualcomm and Huawei, these are two leading companies which are also producing chips which are having inbuilt AI capabilities, right? So quickly just go through the other examples, then I'll try to come to the AI in healthcare. Smart cars. So this we have already discussed, like Tesla, they do already have semi-autonomous cars. And then there are the companies like Amazon and Walmart. They are working heavily in investing heavily for making the drones which can deliver which can deliver to the deliver the products to their customers autonomously, right? So one more thing, that concept that which I discussed in the earlier slides, where I had talked like discussed like how this information is also being exchanged between different machines. The one wonderful example of that mechanism is the Tesla, where one where all Tesla cars are connected all the time, and whatever they learn, they keep on sharing with each other, right? So that information, what's being inferred and being learned upon, that's being shared by all other cars, right? So that's one good example of AI, like how it works in the real time. Also, the social media feeds. Today, in today's world, everybody uses the Facebook, Instagram, Twitter. Now, these feeds are also being tailored based upon the behavior or the web searches or the interaction that you have done on the internet, right? So it always keep on learning based on your behavior, your web searches, your interactions. So all those activities that you do on the internet is being monitored continuously, right? And based on that information that's being extracted by monitoring these behavior patterns, these websites basically tailor your experience, right? Tailor your experience, and they recommend you the content which you are more interested in, right? So the basic concept behind using AI for social media feed is to to make you more what I can call it to be habitual, or uh, uh, like you will be having more interest in the content that's being flashed by these social media feeds, right? So that's one of the application of the AI, where those social media feeds are being tailored based on the experiences that it learns. AI learns by the behavior and the web searches that you do. Now, music and multimedia streaming. Everybody nowadays uses Ghana, Spotify, Netflix, or YouTube. Now, your experience that you have on Google, on Ghana or Spotify or Netflix or YouTube, is also being tailored by the AI application, right? So your AI learns by the behavior, your behavior, like which kind of which category of song you like, which type of videos do you like, and based on your behavior, it's going to recommend you other content as well, other media content as well. Now, this thing is very wonderful. Like if you go on Ghana, many a times I used to listen the same song, because if I'm not searching for the song, then because that's also sometimes a tedious task to find a kind of genre and kind of song that I like. So it's better to use AI for that particular purpose, and AI is going to identify which type of song I usually like, and it will keep on feeding me those type of songs only, right? So that user experience is going to be much more better if we embed AI in these kind of applications, right? So this is really wonderful, like how these applications of AI are making our experience very rich when we are dealing with the media content or music content. But this is kind of a rabbit hole, because if you like, suppose if you go to YouTube and if you watch one type of video, it's going to recommend you similar type of videos, and that's going to be a rabbit hole. You will keep on watching and you're going to waste countless hours in that activity, right? So they are making you uh, more more addicted to this content, because you are getting the same type of data or same type of information that you are interested in, right? One interesting example I want to tell you, like how much AI is capable of. So there is one game which is known as Dota 2, and there is one company which is known as OpenAI. This company is being backed by Elon Musk, and they have recently made a software, more precisely, I should call it AI-based software, which has defeated the pro level Dota 2 players. Now, this is really phenomenal, right? Because a machine is defeating two pro level players in that particular game. Now, this game is a strategy based game where in fraction of seconds, you have to take a decision like what you have to do. At that speed, your machine learning or AI system is performing and defeating the pro level players. It's really phenomenal, right? Apart from that, the ads that you see on the Facebook, those ads are also being curated by the behavior that your AI learn or the AI system learns, and based on the behavior, the type of product that you like, they always try to show you or pop up the images of the product which you are more likely to buy, right? So your that AI is going to learn all the time. It's running 24 hours. It's learning from your interactions, your behavior, your web searches, your content that you are watching, and based on that, it's learning and it's identifying which type of product you can buy, and it's going to show you those type of products only, right? And that's much more useful, beneficial, because if you get recommendation for the product which you are totally not interested in, that advertisement is having no value, right? So that experience of advertisement is also being changed. It's all keep on changing. uh, so this is one another example of AI, how it's affecting the advertisement industry. Now, there are other examples also, which includes a smart home, where the devices are smart. Like in near future, you may see a fridge which keep on looking for your milk requirement. If your milk is about to empty, it would be connected to the internet and it would be able to order milk for you. That's going to be the future of this technology, right? Now, smart home, there are many devices in the home, like there is AC, there can be thermostat, there are lighting elements. Now, they know which kind of environment you like in the home, and they will try to optimize the environment for your maximum efficiency, right? So this is how your devices are going to learn by your behavior, and they're going to optimize. They're going to optimize so that uh, so that you can perform to your maximum efficiency in that particular environment. So they are learning with your behavior. Then another example can be banking and finance. So if I talk specifically about the banking, the customer services, fraudulent detections, like if somebody sending you a fraud message, that can be detected if you do non-conventional transaction on some website, which are being identified as the fraud website. You will be getting some identification, or you would be getting some message that this type of transaction has been done, whether you have done it or you have not done it. So all your transactions are being monitored by some AI-based systems for the fraudulent detections, right? Then customer services. In the customer services, there are many banking websites. If you go onto this website and you start chat with the chat bot, so that chat bot is also a AI bot which learns with the experiences, and just gets better and better and better over the time, right? So most probably, whenever you go to some banking website and you chat, most of the time it's possible that you are chatting with a AI bot. Then navigation and travel. So navigation and travel, the one good example is the Tesla car that we have already discussed, which takes the sensory information from the different cameras and GPS and optimize or not. It's also one of the application of AI. Also, if you use a Google Assistant service to call an Uber, that's also going to be one of the problem related to navigation and travel, right? Or if you say your mobile to book a flight from one place to different place, that's also going to be a navigation and travel problem. Then safety and securities, right? This is also being optimized by AI. I'm not going to go into the deep. You may search, there are different applications of AI in security and surveillance. Then EcoDot, Amazon product, which is the speaker. And this speaker you can use to set the reminders, to set the alarms, to listen a particular song, and there are different applications, so on and so forth. So these are all being working on artificial intelligence. So these are some of the common AI and ML methods, which are artificial neural network, support vector machine, random forest tree classifier, k-nearest neighbor, and there are many more, right? So coming to the AI in healthcare, this is very interesting article that you can find on the internet. It's integration of novel monitoring devices with machine learning technology for scalable cardiovascular management. So in this paper, they have reviewed many technologies, specifically the wearable technologies, which are already available or emerging in order to keep your heart healthy, right? So if you go and search for this article, you will find really a good article over there, and you will see how this area is growing and how it's being very much useful for specifically for the health monitoring. So how it works basically, if you specifically talk about the heart health monitoring, there's a conventional method where we look for the ECG signal of the heart. So this is the how a normal ECG waveform does look like. It is having 5 different components, P, Q, R, S, T. So this is a very typical representation of a healthy heart. If you take ECG signal of a healthy heart, this is how the ECG signal should look like. Now, any deviation in the ECG signal from this typical representation is going to tell you about abnormal heart conditions, right? So the same example where we used AI to classify between dog and cat, now the same AI, if it is being trained with good amount of data, which is also pre-processed, representing your information very correctly, can also classify a good ECG signal and a deceased ECG signal. That means a healthy person and a deceased person who is already developed some kind of cardiovascular disease, right? So in this paper, if you go through, you will figure out that how different type of biosignals can be captured from different part of your body, how these variable sensors can be placed at different part of your body and can be used to take the necessary signal from your skin. Skin, that means these are not the not penetrated one. They are going to be on your on the surface or on the skin, right? So how you can take those biosignals and feed your biosignals to the AI network to understand how a healthy heart or the other healthy parameters of body should look like. And if the parameters, other health parameters as well, I'm not talking about the cardiovascular parameters only, I'm talking about all other parameters. If those parameters are not within the range, it can raise a flag that this guy is having some problem, this parameter is going out of limit. Now in today's time, like everybody is suffering from this COVID-19 situation, and the people specifically who are the patient, they are having their oxygen saturation, it keeps on going down from 100 to 90, 90 to 80, 80 to 60, then 70, and they don't have any monitoring on their SpO2 count, right? So we can have some type of watches which keeps on tracking the oxygen saturation level, and when it falls below a specific range, we will set the threshold, and when it goes below that threshold, there should be an alarming situation, and that alarming situation should be flagged, right? So this is how we can use variable sensor technology to keep monitoring the vital health parameters. Now, this can be keep your heart healthy, it can be used to keep your brain healthy, it can be used to keep your overall your body healthy, right? So these are some of the current and emerging variable sensors. Now, this is one project that we have recently written. In this particular project, we have proposed an idea where we are going to make an ECG belt, and that in that ECG belt we would be having ECG electrodes and amplification system. Then there is going to be small board which is going to take the ECG electrodes, is going to take the ECG signals, is going to pre-process and going to classify if those ECG signals represent a healthy heart or they represent a cardiovascular disease, right? So everything is going to be on board, on the single board. So irregular beat patterns are going to be identified by the board itself. And if there is any alarming situation, then flag is going to be raised. Also, this device can be connected with your mobile application, so you can have live feed from your belt on mobile application where you can see your ECG signal. Also, it is having inbuilt Wi-Fi capability through which you can send this ECG signal to a person who is sitting remotely 30, 40, 50 kilometers away from you, and he can view the heartbeat patterns, and based on the heartbeat patterns, it can identify if you do have any heart conditions or not, probable heart conditions or not. So this comes or falls under the category of remote health monitoring. Specifically, I'm talking about heart remote health monitoring, right? Now, this data can be sent to miles and miles away, and if a person or expert is sitting miles away, he can get the data, he can have a view of your data, and he can identify your heart conditions. So this type of applications are specifically suited for the persons who are sitting in the remote areas or in the mountains, and they don't have regular facility to keep on checking their ECG patterns, right? So this type of application, they can this type of product they can use. So this is a recent project that we have submitted. Let's see if we get this one or not. So there is another application of AI in healthcare is the active prosthetic hand, where what we do, we take the muscular signals, that means the signals which are coming through the muscles. So whenever any of your muscle activates or triggers, there is a neural signal which reaches from your brain to that muscle, right? And that you then there in that particular place where your muscle is being triggered or activated, there is having the facility available to interpret your neural signal to muscular signals. So that interpretation takes place at a specific location of your muscle and get activated, right? Now, suppose suppose there is a guy who is amputee, and he's not having his hand, or maybe he's not having his fist, or any of that sort of thing, right? So in that condition, the signals are coming from your brain till that muscle, but there is no further facilities available to perform the action, right? Because this guy is amputee. So you do have EMG signal available with you, which are the electromyogram signals, but there is no further function is available to take that movement which needs to be taken. So what we can do, we can tap these EMG signals, and by tapping these EMG signal, I mean we are trying to classify these EMG signals to understand the intent of the person, like what kind of movement this guy was willing to do. So there's a very or simple example I try to put in over here, where I have shown the small hand, and in this hand, this is the robotic hand, and we do have two EMG electrodes. These EMG electrodes are uh, going to take the EMG activity, which comes to your arm, and this EMG activity is going to pick in from these EMG electrodes, then it's going to be processed, and based on this processing, we are going to learn what kind of intentions this particular person is having, and based on that, that movement can be done using this robotic hand. So this is my area. This is brain-computer interface. In brain-computer interface, I'm going to go very quick now. I think I have already. So, Sumit sir, is it fine? Like if I take 15-20 minutes?
Yeah, sure.
Okay. So in brain-computer interface, we try to do the similar kind of thing. Instead of taking the EMG signal or the ECG signals, we are having brain electrical activity, which is known as the electroencephalogram signals. So there are multiple electrodes or the array of electrodes which being placed on the human scalp, and we try to extract the brain electrical activity, which is the sum of many neurons which falls right under the scalp, right? So the accumulation of the electrical activity of many neurons is going to give you the brain electrical signals that being picked up by the by the electrodes, and it usually have lot many artifacts and noises, because these signals are in the scale of microvolts, so they easily get affected by the environmental noise and also the other type of activity which otherwise unintentionally being going on in your brain. Like whenever we are taking or recording this EEG activity, your eyes are blinking, your heart is beating, and other activities are also going at the same time. So if I try to record your EEG activity for a particular intention, with that intention also there are many other activities are being taking place in your brain, right? Because your brain is doing a multitasking. So if I am interested in a specific type of information, I'll have to filter out all other information, also the noises, right? So the information that I'm not interested in is called the artifact. And suppose if your EEG activity get affected by the environmental noise or the instrumentational noise, that noise is also going to be filtered, right? So that pre-processing is being done. Then important features are being extracted out of these EEG signals, which are going to give you the better representation of your signals, right? So everything is mathematical over here. We are having EEG signals, which are in numbers. Now, pre-processing is also being done by some filters. Those are also mathematical thing. Then feature extraction is being done by other sophisticated methods. And once we do have features extracted out of these EEG signals, we can define a one type of EEG signal as one category, another type of features as another category, and third type of features as in third category. And with these feature sets, we can train our AI algorithm for detection of a specific type of intention of human brain, right? So for a small example, if I want to identify if a person is happy, he is sad, or he is normal, right? That's also can be done by brain-computer interface, and this is known as the emotion recognition. So what I will do, I will give the AI algorithms a sample of EEG activity that correspond to the happy person. Then there's going to be EEG activity that correspond to a sad person. Then there's a set of EEG activity that correspond to a normal person. And I'm going to feed in my AI algorithm with this sort of information. And your AI algorithm is going to learn after pre-processing and feature extraction. And after training, it's qualified to detect human emotion using EEG signals, right? Now we can do the emotion classification. We can also classify EEG signals to control a mobile robot, right? So if I do have a mobile robot, I want to classify EEG signal in 4 category: for move forward, for move left, for move right, and to stop. I can also train my brain and simultaneously my AI algorithm to interpret my EEG signals to identify my intention to control that mobile robot, right? So this is one example of brain-computer interface, how these AI algorithms can be used for this particular purpose. Also, we can use AI algorithms for detecting different type of diseases, specifically the neurological diseases, schizophrenia, Parkinson's disease, epileptic seizure, mild cognitive impairment, Alzheimer's disease, dystonia, mental workload analysis. So I have put a small set of diseases over here. This list can be really broad, and as we get a good amount of data, and if that data is representing properly the specific type of disease, we can use the data to train our AI to further deploy in the pathology labs, or as a mobile application, so that a person can have an idea if he is having that kind of a disease or not. Now, these things can be used on screening methods. Okay, after screening, he may go to the doctor and look for the final diagnosis. He should visit the expert, but these methods can work as an screening methods, right? So here I put 3 different examples which represent the EEG signals being taken in 3 different conditions. So the A figure represents the normal condition, B represents the epileptic seizures, pre-epileptic seizures, and C represent the epileptic seizures. So here we are trying to classify epileptic seizures out of EEG activity. So visually, you can also see there is some difference in the EEG activity. There is some pattern is embedded in this EEG activity. The same pattern we try to extract using feature extraction methodologies, and that features are given to the AI algorithm to learn like how an EEG signal look like when a person is normal, when he's having pre-ictal EEG activity, pre-ictal epileptic condition or ictal epileptic condition. So this is just an example like how EEG signal does look like and how they can be used to train the AI algorithms. This is one of the framework which I had developed, I think 5 or 6 years back, to diagnose epileptic seizures using EEG signals. Here you can see I had used, at the last, you can see we have used 3 different methods for ranking the features, like how those features can be ranked, and in that ranking pattern, we can use those features to train our model for classifying among normal, pre-ictal, and ictal EEG activity. So this is recent work that we are doing. This is one book chapter that we are about to complete, and very soon you will see this in publication, where we are trying to classify a healthy and schizophrenia subject. So we have used some transforms. One transform is known as MSST, and we have tried to extract time frequency information out of those EEG activities, and then we have used different type of models like VG16, BILSTM, CNN, which are very modern AI algorithms. So we have used these algorithms to classify between these 2 types of EEG activities. One is the healthy and the schizophrenia one. Now I am going to move fast, and so this is another work that we have recently been carried out in my lab. We have tried to classify between COVID and non-COVID patient using their chest X-rays, right? So we do have 4 chest X-rays of the same person being taken at a different day. So first one was taken at first day, then the 4th day, and 5th day, and 7th day, and you can see like how that virus is occupying your lungs area. So this is the chest X-ray, which is basically representing the lung area. So you can see how that virus is capturing your lung and how it's being infected, or the progress of infection you can see from day 1 to day 7. Now, if we do have many number of such examples, we can use these examples to train our AI algorithm. And once your AI algorithm is trained, you can use that trained AI algorithm as an screening method to detect a person is having COVID, or he's not having COVID by using their chest X-rays, right? So this type of model we had designed, where we had used multiple machine learning algorithm instead of single one. So we do have 7 models, 7 machine learning algorithm, and we have organized or designed this method in such a way that we can get maximum out of each model, right? So that interaction of model is being placed in such a way that we are getting the high classification efficiency between the chest images. And we have classified those chest images in 4 categories. One is the COVID-19, then pneumonia, bacterial, viral, and healthy one, right? These are some of the works that we are doing currently in TIIT Patiala. Here we are trying to design a brain-computer interface which can be used to control a mobile robot using P300. This is a specific type of EEG activity which occurs 30 milliseconds after a particular stimulus, right? So we are trying to extract this P300 type of EEG activity to drive a brain-computer interface, which finally is going to use as an assistive methods for person who are having difficulties in controlling the assistive devices or the applications. Another work that we are doing is we are trying to develop the methods which can be used for filtering and pre-processing the EEG activity. So one of the example I do have over here in the A activity, in the A graph or A figure, you can see raw EEG activity. However, in the B represent the corresponding clean EEG activity, which is having artifacts removed and other high frequency disturbances and noises being removed in B figure, right? So this is another work which we usually do over here. This is a new thing that we are working on currently. We are trying to analyze the mental states of these subjects. I would call them as an student because these experiments are being run on the students currently, and we are trying to record their EEG activity using wired or wireless EEG devices. And while taking or recording EEG data, those subjects were engaged in watching some video content. So we do have 3 different type of video content. One was some entertaining video, then second one was some active learning video where we showed our student some videos where they had to draw something. So related to drawing that video was. So there was some drawing was going on and similar drawing they have to also do on the pages. So we can consider this thing as an active learning. And the last category where we had shown them some e-content where they had to experience some video lectures being designed by our own faculty members. So you can clearly see like how each activity varies for the person when the subject was engaged in e-learning video content and he was engaged in entertaining video content and active learning video content. So these data is being recorded in my own lab, and then we have calculated power spectral densities. This is not raw EEG data. This is the power spectral density which is being calculated on EEG data. So this is the EEG headset that we also do have in our lab. And we use sometimes this wireless EEG headset to record EEG activity. So this is one workshop that we organize every year. In 2018, it was organized in Russia. Then in 2019, it was in Dublin. Then 2020, due to COVID-19 situation, it was in online mode. This year also, we are going to organize this workshop. So if anybody of you who is already in this area and is willing to publish their research papers, or preliminary findings, they can go to internet and find for AIDL HCSY. This is a workshop which is being organized under ICUAMT conference, which is a very renowned conference in this area. And I think it's going to be 14th series conference this time. So these are some of the online resources from where you can learn about AI. You can go to a Coursera website, and on the Coursera, there are very good courses are available. And if you are very new novice in this area, then you can look for very fundamental course like AI for everyone. And later on, you can move forward with machine learning, introduction to artificial intelligence, AI in healthcare, and many more. So there are different courses. Their certifications are also available. So if you're interested, you can go to Coursera. You can explore like which type of course is much more suitable to you, right? Also, you can go to YouTube. There are many channels are available like Deep Learning AI. So this is very good channel, Deep Learning AI. It's being run by a guy known as Andrew Ng. I'm also going to talk about him. So on this channel, Deep Learning AI, you will get very fundamental and also advanced level video content over there, then applied AI courses and many more. So these are few of them. There are many more of them, right? So you will get many channels and good resources, right? So this is guy Andrew Ng. I would suggest you go on Google and also search for this person, Andrew Ng. He is a British-born American computer scientist, And he's also founder of Google Brain, which is one of the pioneer in this particular area of AI. And he has been former chief scientist of Baidu. He's also the founder of Coursera. So on Coursera, many of the courses you will find which are being run by Andrew Ng. He's a very renowned person in this area, and many good content is being regularly uploaded by Andrew Ng on his YouTube channel, which is Deep Learning AI. So these are some of my publications. Although I was about to, I was willing to discuss something about them, but now I think its time is already over, so I'm not going to discuss them. So this is me, Dr. Rahul. You can also contact me on my email ID, rahul.upadhyay@thapa.edu. I do have my Gmail ID. You can also visit and see my page on thapa.edu. You can also search me on Google. So thank you very much for your time and patience.
Thank you, Rahul. Thank you very much.
Thank you, sir.
It was very informative session.
Sir, actually, I was not having an idea like who is going to be the prospective listeners. So I tried to keep it very basic and then to the advanced level.
But it was very informative, and just we know the advanced techniques of AI.
Yes, definitely. Yes, sir. The presentation has been successful. There is no doubt about that. And yes, Dr. Rahul, you deserve this round of applause, virtual round of applause, I would say, which has been created by Dr. Sumit Nema, sir. So you definitely
Thank you
deserve
very much.
this applause.
Thank you, Rahul, sir. Thank you.
Thank you very much, sir. Thank you for calling me, and it's been an opportunity for me as well.
Students, you have any query, bete? Do you want to ask any question regarding AI? They have asked some question in chat box actually.
Okay.
Just you check it. Siddhant Kare. Siddhant, you're online?
Yes, sir.
You may ask the question what you have typed in the
Sir?
chat box.
Sir,
Yes.
I have basically a question about the data set thing. So
Yeah,
in the mostly medical field, the required data set is very less and then not that accurate or something. So basically
Okay.
there are very noisy thing. How can we optimize that problem, or in the production level, is the overfitting the training training data is a good thing or not?
Okay. Data problem, you're talking about the data. So yeah, earlier it was a problem like 10 years back when I was I had started working in this particular area. That time I used to feel that data is not available, but these days plenty of data is available. Like if I talk about schizophrenia disease, I talk about Parkinson's disease. If I talk about heart related disease, different type of arrhythmia, or even if I talk about image data sets, there are many websites which are available and they are continuously providing these type of data, right? So I would name one very famous website which is known as Physionet. So this Physionet basically deals with the signals related data set. So you will get the data related to EEG, ECG, EMG. So this category of data you will get on Physionet. For video type of for the image data set, you can also look for the Kaggle website. And apart from that, what you can also do, if you are interested to work in a particular area, may it be a migraine disease related area or heart disease related area or any other area. If you read some of the journal papers, some of them use the online available data set and some of them record their own data set. If you request for the data set to the authors of the papers, many a times they are very happy to provide that data set, right? Many a times they also provide the link of their data set in their publication itself, right? So you will have to like dig a little bit, but few of the resources like the Physionet that I have talked about, so they are having Physionet ATM, where you can get plenty amount of data, different type of EEG activity, you can get different type of heart related data, you can also get. And sometimes it's very good to work on the online available data set, because in that case you would be in a condition to validate your results with already published results. Because if you are recording at your own place, if all other parameters are not constant, all the conditions are not constant, there may be a question like whatever accuracy you have got, is it comparable to someone else's work or not? So it's always better to work on the standard data set, so that you can compare your accuracies or performance with others' works as well. Second question, you talked about the overfitting. So overfitting is not a good thing. Overfitting usually occurs when you are having crunch of the data set. You are having less amount of data and you are training your AI algorithm with that amount of data. So what will happen if you train with less amount of data? Your network will be performing very good on the similar set of data, or the very similar type of data. But if your data is having little deviation than what you have used to learn your algorithm, your classification is going to be wrong. So there are more chances of having the wrong classification in that sense. So that's why it's always good to generalize your algorithm rather overfit.
Thank you, sir. Thanks.
Any more questions? Someone ask any question? Actually, they have typed here in the chat box, I think.
Yeah, but there are so many messages.
There are so many messages. What is AI camera? I think it is already explained in the session.
Yeah, actually I have tried to give you an idea where like what an AI and what are the different applications. But also there are many resources are available, and it's a vast field. It's very difficult to like club in everything in one single lecture. You can look on the online resources online resources, and you will get much more than what you demand for.
Definitely. Prasan sir?
Yes, sir. I'm here, sir. I'm here. Definitely, yes.
Should we go for the thanks ceremony?
Yes, definitely, sir. Dr. Rahul, sir. We, on behalf of the Global Nature Care Centers Group of Institutions, thank you a lot. Our gratitudes towards you, sir. Whenever you come to Jabalpur, sir, do come to the Global Engineering College. We shall definitely welcome you. And of course, sir, Jabalpur is your home. So
Yes,
whenever
sir.
you come to Jabalpur, after the pandemic, of course, definitely, sir, we will receive you with open arms. Definitely, yes.
Thank you, sir. Thank you.
Okay, sir. Thanks very much, sir, for joining.
Thank you,
Okay, sir.
Rahul.
Thank you very much,
Thank
sir.
you very much.
Thank you, sir.
very
Thank
much.
you for calling me. It has
Thank
been
you.
wonderful experience. Okay, sir. See you.
Okay. Okay, bye.
Bye, bye,
Okay,
sir.
sir.
Bye.
Prasan sir?
Bye, sir.
Then
Prasan, sir.
Okay, yes, dear students, so now the session for paper presentation is about to begin. Okay, and the session will be lasting up to 4:15, and then a plenary section is also scheduled at 5 o'clock. So at 5 o'clock, all the students will be joining here at this platform, while meanwhile, the students have to go for the Google Meet link where the paper presentation will be beginning in a few minutes. So see you at 5 o'clock at this platform for a plenary session that will be taken up by Mr. Sanket Vaidya, the Computer Talent Acquisition Manager, Persistent System. So, Sumit, sir, we take leave now from this platform.
Yeah, sir. We come back
Okay.
by 4:45.
Yes, definitely. All the students are expected to join this platform by 4:45 today, 5:45 p.m. That is. Thank you very much for your company.
Okay,
See you
sir.
next time. Thank you. Thank you very much. Thank you, sir.
Proper